We looked at the carbon brief report on El Nino anomalies we can expect this year as the El Nino keeps growing. Washington Post has its own take on this. Obviously, they are related. The Washington Post is much more of a newspaper as opposed to Carbon Brief, which is usually focused on climate alone and goes into much deeper uh, levels of reporting climate related stories. So I just wanted to bring a little contrast, and Washington Post does it as extremes or percentiles as opposed to the details that we looked at from Carbon Brief report. What will El Nino bring where you live? Maps show its wide-reaching impacts. Doesn't mean they are downscaling to neighborhood scales, but they are going by regions as well. Global weather patterns are starting to change. These forecasts will be updated regularly, so Washington Post plans to update these in the coming months as El Nino keeps growing. What are the things that have already happened? Hurricane season is quieter. Monsoon has been quite erratic over India. Is that directly related to El Nino? Seems more like a mix of El Nino and global warming, and I've written about this elsewhere already. So sea surface temperature anomalies in the central equatorial Pacific, when the article was published in August 19, we were here already over 2 degrees C in terms of the anomalies, and record El Nino is just above that from the past instrumental records. I think 97, 98, or maybe 2015, 16 was the one. So you are expecting to keep going up. Maybe you will reach 4.1 degrees C according to some mean forecast from the models that the Washington Post is using. Much anticipated El Nino that developed this summer is on track to become the strongest ever recorded, with cascading effects on global climate peaking late this year into next, and next year will be warmer, so we'll be discussing the thresholds of warming, global warming crossed instead of just the El Nino. Why we completely forget about global warming during an El Nino is not very obvious because it's not gone away really. But water temperatures in the central equatorial Pacific Ocean, where El Nino is measured, have been at record levels already for more than 2 months straight from June. El Nino's effects have already been felt around the planet. The higher frequency of heat domes worldwide, the non-stop temperature records in Peru, and deadly storms in Chile can all be linked to this pattern, as can be the destructive typhoons in the western Pacific Ocean and the relative calm of the hurricane season so far. So here we are generally taking known El Nino teleconnections like Peru and Chile, which are much more robust than some of the others, like the frequency of heat domes, and we are saying they can be related to El Nino. Okay, and this event is poised to grow even more intense. The Washington Post is tracking monthly updates to the forecast data, with the latest updates from early August showing that ocean temperatures in the central Pacific continue on a record trajectory. They are projected to reach an average peak of around 4.1 degrees Celsius or 7.4 degrees Fahrenheit above the average in December, more than a degree higher than a record-breaking El Nino in 2015. So 2015 has been the strongest in instrumental record. The projected peak strength of El Nino has increased compared with the forecasts issued in July. So already each forecast is showing a stronger El Nino than before. Doesn't mean they are right, because remember, models don't do the stochastic forcing and the westerly wind bursts that are so important, but when they initialize a new forecast, that information is partly fed in, so they may be capturing the right growth. Because raising temperatures of the raising temperatures of the ocean requires far more energy than warming the land, that shift would represent an extraordinary amount of warming, even though we have to remember the heat that is showing up is often already collected in the ocean and is just converging into the tropics and moving eastward, but the Bjerknes feedback is already here. So the sea surface temperature anomaly patterns are weakening the SST gradient, pressure gradient from eastern Pacific to the western Pacific, weakening the trades, reducing the upwelling further, and they are beginning this positive feedback, which is what makes the SSTs grow. So here we are, strongest El Niños on record, and what we just saw here. So we are jumping way out of those already. El Nino index sea surface temperatures in the central equatorial Pacific relative to the average from 1993 to 2016. The base periods you can choose longer, 1981 onwards for some. For whatever reason, Washington Post has picked these, but these things will just shift based on the baseline. In the graphics above, the forecast scenarios represented by the red box show this El Nino reaching heights by the end of the year that have never been seen before. This graphics and the ones below that follow will be updated regularly as the El Nino and global impacts grow through the end of the year. And El Nino, of course, is expected to drive significant weather effects if it reaches this magnitude, which could end up stronger and longer lasting global temperatures, probably reaching new heights as well, while patterns of drought, floods, heat, and humidity will shift across the planet. These are a given. The challenge is exactly where that will happen and whether that will stick to the known composite El Nino teleconnections, or are global warming already shifting them. And we know that global warming is already shifting many of the patterns and mixing with the El Nino. El Nino itself is a mini global warming, so it amps up the global warming typically the following year, but already this year it's adding ocean heat as well. Already sea surface temperature forecasts suggest that this El Nino will top the most historically intense event on record, probably by a wide margin. Those events occurred in 1877-78. When you go back that far, data is always tricky. 1888-89, 72-73, 82-83, 97-98, and 2015-16. Even the 72-73, 82-83 data can be not as rich as what we see from 97-98 to 2015-16. Thus, this unprecedented warming may also bring an element of mystery, with some uncertainty around the extreme nature of the impacts that El Nino might trigger. So we have to be careful. What is an El Nino? We can skip these details because we already looked at this quite a bit. So this is the December sea surface temperature forecast relative to 1993 to 2016. And we saw the top ranges in the range of 4.1 or so, but here some local hotspots of maybe 5 degrees will be reached. Coasts are warming really, really fast this year. These are called extreme El Ninos, and it's starting from here and extending this way, and westerly wind bursts keep pushing warm waters eastward. Deeper thermocline, weaker gradient, weakening trade winds, all those good things are happening. So I will skip this part. What happens in the tropical Pacific doesn't stay there, so changes in thunderstorm patterns cause storm carrying ribbons of wind in the upper atmosphere called jet streams to change the speed and direction, affecting weather patterns around the globe. Current El Nino was kick-started by a wind burst in a remote part of the western Pacific during December itself last year, when an El Nino was a La Nina-like condition was still in place. Those wind bursts kept forming, shifting copious amounts of warm water west to east across the Pacific through oceanic features called Kelvin waves, which push the thermocline down. If you don't know what a thermocline is, please follow up on my podcast. Oceanography course explains it in detail, but there are also detailed El Nino oceanography podcasts. There are also El Nino podcasts. That has led to summer-like weather in Peru during winter and devastating storms in Chile. They typically occur later in the El Nino cycle. December, January, February is when the El Nino peaks, and that's when you have summer in the southern hemisphere. But this winter, June, July, August has already been quite anomalous. How will this El Nino impact the weather through October? The latest outlook of possible extreme weather ripple effects from this El Nino is based on 3-month forecast data released in early August. These outlooks don't predict specific weather events. That's very critical, not very local. Instead, they show where unusually extreme climate conditions are more likely, often because of frequent storms or persistent departures from normal weather patterns, often attributable to El Nino, especially when it's this strong, but very hard to separate from global warming at this point, like the El Nino, the Indian monsoon. This year's phase is expected to have a profound upward influence on global temperatures, with more than 80% chance for 2027 to become the warmest year on record. Good thing they don't mention 1.5 degrees C. That's because warmth that builds up along the equator in the Pacific Ocean gets released into the atmosphere and spreads around the planet. Through October, around 2.9 billion people across the planet have at least a 10% chance of experiencing temperatures that are in the top 5% of historical values for the time of the year at their location. So chance of extreme high temperatures from August to October. Oceans, already lots of heat waves, and they will trigger extreme rainfall on land. And you can see El Nino, of course, will show up very strongly and broadly in the Pacific in terms of percentiles. These are probability of pardon me on that. I managed to move the mic, so hopefully it didn't produce a scream in the recording. Probability of average temperatures exceeding the 95th percentile on the base of 1981 to 2025, different base than we saw before. So large parts of Africa, Indian Ocean into maritime continent. So of course, you will have lots of rain, floods, landslides, etc. Here, maybe cyclones, typhoons are already happening, but droughts, wildfires, dust storms, etc. over here, and all kinds of marine impacts here. We have to see what the post-monsoon cyclone season will do here, but this is just about extreme high temperatures in the 95th percentile. These places may experience very unusual warmth compared with what is normal. Southern and northwestern United States here, Caribbean and Central America and northern South America, over here, large parts of Europe and Africa, Middle East, India, Indonesia, and Southeast Asia. So typically, Africa's signal is not, the ENSO teleconnections are not very strong, but El Nino affects the jet stream and the Arctic sea ice, and those tend to affect the doming, the jet split, the heat waves, etc. And Europe has had severe drought and already, I think, 6 very strong heat waves this season, very unusual. So heat domes are forming more often. So this is one place where I think the global warming and El Nino are working together, and it's not just the El Nino teleconnection. El Nino teleconnections. El Nino causes cells of high and low pressure to shift and in some areas become stronger and more persistent. These changes in atmospheric circulation increase the risk of drought in some regions and extreme rainfall in others. Around 1.3 billion people live in areas that have at least a 10% chance through October for much less precipitation than normal, while 942 million live in areas where there is at least a 10% chance for excessive precipitation. So unlike Carbon Brief, Washington Post is taking regions, counting populations, and talking about exposures of the number of people, which is obviously shocking in terms of hundreds of millions, crossing a billion. Change of extremely dry conditions in August to October. This part, is it playing out this way already? Yes, a monsoon is quite dry over here, but the patterns are quite complicated, so you have to be careful. Over the ocean, data is not always that strong to make such relations, but these are model forecasts, so you have to go and see by October how many of these will come true. This is already quite dry. Strongest droughts here happen in July to August to September or so. So this will most likely come out this way. there are other, this will be wet, but there are dryness here. Brazil and parts of Argentina will get wet. Africa generally has lots of signatures, but these forecasts are not showing them. Wetter in East Africa, drier or southeast, and so on. These places have a chance of seeing extremely dry conditions compared with what is normal. U.S. Northwest, where wildfires have raged, and the Caribbean, Central American, and Northern South America, parts of Northeastern Africa and the Middle East, swaths of India, Indonesia, Southeast Asia, and several South Pacific island nations. Chance of extremely wet conditions till October. These are warming very rapidly, and this shows up in wet conditions, but not so much in the temperature signature, which seems okay. Of course, this region will get, shifted convection, which will dry out this region, but put much more rain over here, especially over here. This will come in the winter, but already by October, you may see some small chances of extreme wet conditions. Mayu, Bayu, and these parts of East Asia are already seeing some. Typhoons are playing out and putting a lot of rain here. Many places are getting doused, and ITCZ shift may show up here. On the other hand, these areas may see much more precipitation compared with what is normal, which can lead to flooding. Parts of US, Intermountain West, South, swaths of South America, including Peru, Ecuador, Chile, Argentina, Bolivia, Paraguay, and southern Brazil, Western and Southern Europe, which would greatly contrast with ongoing drought there. Parts of Northern and Southern Africa, as well as Somalia, Kenya, and Ethiopia, much more precipitation. Pockets of Middle East to Central and Eastern Asia, Southern Asia, as well as Kiribati, Guam, and Northern Mariana Islands, and Hawaii in the Pacific Ocean. Hawaii saw a major cyclone just recently. Although El Nino is an important driver of global weather patterns, it isn't the only one. These predictions incorporate many different factors that influence climate. Seasonal outlooks like these are also most accurate near the tropics. So just the caveats that when models do predictions, they are not trying to just look for El Nino impacts. They are doing global circulation coupled responses, and they are producing these anomalies, and many of them are consistent with El Nino anomalies and teleconnections, but usually there are also other drivers of warm anomalies. For example, if you see extreme dry conditions, you have to understand what other temperature patterns may be driving these. So if you look at extremely high temperatures, there are high temperatures here, and of course here. So they will all have, and here, they will have local and remote impacts on rainfall as well, and not just the El Nino. Okay, so just remember those. Although El Nino, and rainfall patterns in general, temperature patterns are more reliable, but rainfall patterns tend to be better done by the models in the tropics when it comes to long lead forecasts like this out to October. These patterns of potentially unusual weather can shift with each forecast update. For example, the impact across the US typically peaks during winter, when the west, south, and east can frequently face heavy rain, and the colors of the maps will probably reflect that threat as the winter approaches. Chance of extremely high humidity, again, if temperature and humidity are closely related, that shows up here. So obviously significant warm anomalies here will bring significantly high percentile of humidity, and surprisingly here it's not showing up. October heat is going to be massive, I think, here. These regions, of course, Indian Ocean, and what that will mean in terms of the withdrawal of the monsoon, the cyclogenesis over the Arabian and Bay of Bengal seas, Bay of Bengal and the Arabian Sea, it's not clear, and what the typhoons will do as the El Nino continues to grow isn't obvious as well. well, isn't obvious either. El Nino will also drive higher humidity than normal. Around 2.2 billion people across the globe have at least a 10% chance of experiencing humidity levels that are in the top 5% of historical values for the time of the year. There is a concept of internal variability, which means 10% chance is not that high if you just consider how much change can happen just due to random reasons. But we're talking about risk, and we must prepare for these risks and not worry about statistics as such, right? If whatever no regret decisions can be made in setting up shelters, hydration centers, free transportation for people and so on can go on, even if these predictions are not perfectly reliable at local scales. That includes areas, so high humidity, extreme humidity will include west coast and intermountain west of the US and a stretch from southeast to the mid-Atlantic. Humidity much higher than normal is also likely across large parts of the global tropics, driving up the risk for heat stress and mosquito-borne illnesses in some places. Mosquito-borne diseases and diarrheal diseases, waterborne diseases are going to explode. There's going to be water issues because of all the droughts, and there are going to be water issues because of all the extreme rainfall as well, and they both bring health issues. How much is climate change to blame? Ocean temperatures are rising mostly because of climate change. That includes the key stretch where El Nino is measured, even though East Pacific has been cooling. To distinguish warming caused by El Nino from the long-term warming of the oceans, scientists have developed a new climate change adjusted index, which I have discussed in another podcast, which is now used by NOAA, National Oceanic and Atmospheric Administration, and climate agencies in Europe, originated in Europe, as well as Austria and New Zealand. Rather than looking only at temperatures compared with the average in the central equatorial Pacific, just the local anomaly with respect to local climatology, the new index compares temperatures in that region with the average temperatures across all tropical oceans, because they're all warming and they're all having an impact. 2023, as we discussed already, was an ocean dynamic El Nino, likely kicked off by the warming in the Indian and Atlantic Oceans. In other words, it measures how much warmer the El Nino region is than the rest of the tropics, independent of El Nino. So this is how that does it. The relative temperature difference is closely tied to the shifts in the tropical thunderstorm activity, which help drive the changes in weather patterns associated with El Nino around the world. So traditional El Nino index, as we saw, puts the forecasts here, whereas if you look at the RONI, Relative Oceanic Nino Index, it will bring it down by this much, climate change adjusted index. And that's not a trivial difference, because the corresponding teleconnections can be massively different, and we have to see energy balance, how that works out, etc. But the gap between the traditional El Nino index and this new relative index represents the amount of background ocean warming included in the traditional measurements. The latest forecast suggests that the gap will be around 0.65 degrees Celsius or 1.2 degrees Fahrenheit during El Nino's expected peak in December. While that might not sound like much, even that additional warming increases the atmosphere's moisture carrying capacity. That's why I'm saying El Nino teleconnections are now closely tied to global warming. Air can hold about 4% more water vapor for every degree Fahrenheit of warming, 7% per degree C warming, which can amplify precipitation extremes around the planet. Okay, so I wanted to include it because it's a slightly different way of thinking than the carbon brief, and still very useful. And we have time, it's not a course. I can keep on putting up these podcasts on YouTube, and you can watch them as and when you have time if you have interest. So see you in the next topic on El Nino.